What's up guys, this is Massey. Welcome to another video. This video I want to solve you another example for relative motion and relative velocity. It is saying that a train travels due south at 30 meters per second relative to the ground in a rain that is blown toward the south by the wind. The path of each raindrops makes an angle of 70 degrees with the vertical as measured by an observer stationary on the ground. An observer on a train, however, sees the drops falls perfectly vertically. Determine the speed of raindrop relative to the ground. So we can say, since the raindrops fall vertically relative to the train, it means that there is no horizontal component of velocity. So the horizontal velocity of raindrop is going to be will be equal to the velocity of train, which means that the relative velocity in horizontal direction is 0. So the horizontal component of raindrop will be equal to the velocity of train relative to ground, so it's going to be 30 meters per second. And we can have such a thing here, theta is 70 degrees, and the velocity in this direction is going to be 30 meters per second, and velocity in this direction will be, let's call it VV. So that will be opposite divided by adjacent, so tan theta will be 30 degrees divided by vertical velocity. So tan 70 degrees is going to be 30 VV. So VV is going to be 30 divided by tan 70. That's going to be 10.9 meters per second. So now this is the vertical component of raindrop. We need to find out the speed in total. So we can say that's going to be horizontal speed squared plus vertical speed squared. It will be going to be 10.9 square plus 30 square. That will be 31.9, or we can say it's approximately 32 meters per second. So that's the speed of raindrop relative to the ground. So that's the final answer. I hope you enjoyed this video. Please leave me a comment if you have any question and get back to us as soon as possible. Thank you for watching and have a great day.